Welcome back, mathematicians. In this video, we are going to learn how to solve oblique triangles, specifically looking at the side-side angle case, resulting in two triangles. To solve an oblique triangle means to find the lengths of any unknown sides and the measurements of any unknown angles. This case gives us two known sides and an angle that is opposite one of them, and this is referred to as the ambiguous case, because the known information may result in one triangle, two triangles, or no triangle at all. To solve this triangle, we would use the law of sines. For a triangle with sides A, B, and C and opposite angles A, B, and C, we would use the proportion sine of angle A over side A is equal to sine of angle B over side B, which is also equal to sine of angle C over side C. We will use this diagram to illustrate the information we're given for side-side angle. In this case, we're given angle A and the opposite corresponding side A and side B. We should first drop an altitude or height for this triangle, which forms a right triangle using side B, angle A, this base, and then the altitude or height. Using right triangle trigonometry, we can then define the altitude or height as B times the sine of angle A. Our goal then is to compare side A to side B and side A to the altitude. Now in this case, we're given side A, angle A, and side B. However, that information could change, meaning the labels could change. So the goal is to remember that you're comparing the side that is opposite the known angle to the other side and the altitude. So when side A is less than side B, and when side A is greater than the altitude, we know that we have two triangles. So let me go ahead and draw out the two triangles to illustrate what they look like. The first triangle is an acute triangle, and it's formed of side B, side A, and angle A. However, this angle B, which I'm going to call B sub 1 since there will be two triangles with two angle B's, this angle B sub 1 is an acute triangle. The second triangle that exists is this triangle here that is an obtuse triangle because angle B sub 2 is an obtuse angle. So those are the two triangles that result in the information that we are given. In this example, I'm given side C, side B, and angle C. I'm going to draw myself a picture to illustrate what I'm given and to figure out whether this information results in one triangle, two triangles, or no triangle. I'm going to put the known angle of 40 degrees at the bottom left-hand vertex, which means side C has to be opposite it, and I'm going to put side B right here. Now my goal is to find the altitude of this triangle, which is also called the height. What I know is the height is equal to 9 times the sine of 40 degrees. Using my calculator to come up with an approximation, that would be 5.79 units. My goal now is to compare the known side that is opposite the known angle, which in this case is side C, comparing that with the altitude and the other side. So what I see here is that side C is less than side B, and side C is greater than the height, which means what results is two triangles, meaning that our information satisfies two different triangles. Let's start by solving the first triangle, which is an acute triangle, and let me label the unknown angles and side in this triangle. I know that this angle would be angle B sub 1, this angle is A sub 1, and this side is A sub 1. Again, we're using subscripts because of the fact that we have a second triangle that would also be labeled with angle A, angle B, and side A, which means that to differentiate between the two, knowing that they will not be the exact same values, we have to use subscripts. We now need to start solving this triangle by finding the value or measurement of angle B sub 1. To do this, we're going to use the law of sines. So what we have is sine of angle B sub 1 over the corresponding side, which is 9, is equal to sine of 40 degrees over the corresponding side, which is 7. My goal now is to solve this proportion, and we will use cross multiplication to do that. So what we get is 7 times the sine of B sub 1 is equal to 9 times the sine of 40 degrees. Solving this for B sub 1 means I'm going to divide both sides by 7. So I have sine of B sub 1 is equal to 9 times the sine of 40 degrees divided by 7. And then I take the inverse sine of both sides. And so what I get is B sub 1 is equal to the inverse sine of this expression 9 times sine of 40 degrees over 7. I'm now going to use my calculator to evaluate the approximation for this. And the approximation for this expression, inverse sine of 9 times sine of 40 degrees divided by 7, is about 55.73 degrees. So up here I'm going to put the values of all my unknown angles and side. So we have b sub 1 is approximately 55.73 degrees. Next, I'm going to go ahead and find angle a sub 1. To find angle a sub 1, what I know is that the sum of the interior angles of all triangles is 180 degrees. So angle a sub 1 is equal to 180 degrees minus the known angle of 40 degrees minus the known angle we just found, which is 55.73. Finding this difference, we determine that angle a sub 1 is equal to 84.27 degrees. So angle a sub 1 is approximately 84.27 degrees. My goal now is to determine side a sub 1. To do that, I'm going to go ahead and once again use the law of sines. So I have sine of angle a sub 1, which is 84.27 degrees, divided by side a sub 1, and this is equal to, now here you can pick either angle and its corresponding side, meaning b sub 1 and side b, or you can choose side C and angle C. I'm going to choose C because these two values are exact. So we have sine of 40 degrees divided by 7. One more time, we're going to cross multiply to solve. So what I end up getting is a sub 1 times sine of 40 degrees is equal to 7 times sine of 84.27 degrees. We should now divide by sine of 40 degrees to both sides, and what we get is a sub 1 is equal to the exact expression of 7 times sine of 84.27 degrees divided by sine of 40 degrees. We're now going to use our calculator to find the approximation, so a sub 1 is approximately 10.84 units. And so now we have solved this acute triangle that satisfies the information that we're given. But there exists a second triangle that we now need to solve for. The information we're given here is the same, where we have side C of 7 units, side B of 9 units, and angle C of 40 degrees. We know that this results in a second triangle that happens to be obtuse. In order to solve for that second triangle, I'm going to redraw the first triangle, which we said was 40 degrees. I put it as my bottom left-hand vertex. The opposite or corresponding side was 7 units, and we have side B as 9 units. We also need angle B sub 1, which we said was approximately 55.73 degrees. What I'm going to do now is draw the obtuse triangle that we're trying to solve for. So this is the obtuse triangle we are trying to find any unknown information for. What we see here, or what we know, is that this side and this side, which are both sides C, are congruent. And that means that because that triangle right here is an isosceles triangle, again, sorry, my picture is not drawn to scale and not perfect, but we know that that triangle is an isosceles triangle, which means that this angle here is also congruent to this angle, making it 55.73 degrees. I'm going to label the information I'm trying to find with that green obtuse triangle. So with that green obtuse triangle, I am trying to find angle A sub 2, I'm trying to find this angle B sub 2, and I'm trying to find side A sub 2. We're going to start by finding angle B sub 2, and what we know is that angle B sub 2 is supplementary to the 55.73 degree angle, which means that angle B sub 2 is equal to 180 degrees minus 55.73 degrees. This gives us a difference of 124.27 degrees. So we have angle B sub 2 equal to 124.27 degrees. We now need to find angle A sub 2 and angle A sub 2, again using the information or the fact that the sum of the interior angles of a triangle is always equal to 180 degrees. I'm going to take 180 degrees minus the known angle of 40 degrees minus the angle we just determined or found, which is 124.27 degrees. This gives us a difference of 15.73 degrees. So now we know A sub 2, angle A sub 2, is equal to 15.73 degrees. We now need to find side A sub 2. To do that, we will need to use the law of sines. So we're going to use sine of angle A sub 2, which is 15.73 degrees, divided by side A sub 2 is equal to, and again here we have a choice, but I'm going to use angle C and side C because they're exact. So we have sine of 40 degrees over 7. We are going to cross multiply the proportion to get a result of side A sub 2 times sine of 40 degrees is equal to 7 times sine of 15.73 degrees. Dividing both sides by sine of 40 degrees means that we have a result of A sub 2 is equal to 7 times sine of 15.73 degrees divided by sine of 40 degrees. Now using our calculator to approximate the value of side A sub 2, we get approximately 2.95 units. So now we know side A sub 2 is equal to approximately 2.95 units. And we have now successfully solved for the second triangle that results given this information of side C, side B, and angle C. All right, guys, good luck.